Hi, this is Dr. Adrienne. Welcome to Health Bite, the podcast where we explore all things health and wellness. Hey there, podcasters. Welcome back to Health Bite, the podcast created to provide you with small, actionable bites to support you in your path towards better physical, mental, and emotional well-being. I am your host, Dr. Adrienne, and I am so happy to be back here with you this week. This week, we are talking about a fascinating discovery in medicine and science called epigenetics. Epigenetics refers to the way in which our behaviors, our environment, and other like factors influence the expression of our genetic material. Our genes are fixed. However, we now know that the expression of those genes is much more dynamic than we once thought. And in fact, our behaviors, our choices, and our environment do affect our genes. So let me explain a little bit about how this works. Our genes are essentially the instructions or the coding for our features, our personality, our health, and essentially everything that makes us physically who we are. Our genes are fixed, meaning that they don't ever change. They are inherited or passed down to us from our parents. And essentially, we get what we get and we don't get upset, or at least it won't make a difference if we do. However, we know that we can turn on or off the expression of those genes through our behaviors, our choices, and our environment. So how does this happen? Essentially, there are regions of the genetic material, again, that code for genes. Those are what, again, make up our attributes. But then areas in front of those genes that determine whether or not those genes get turned on or expressed. And there are ways in which we can change or modify that material, that genetic material, through chemical changes. For example, there is a process called DNA methylation. It occurs when a chemical molecule is added in front of the genes to the DNA, blocking the ability for that gene to be read and processed. DNA methylation, therefore, essentially can turn on or off a gene such that it cannot be read. Another process is called histone modification. Histones are tiny proteins of which our DNA is tightly wrapped around. Our DNA must be unwrapped in order to be read. And again, there are chemical modifications that can be made to the gene or to the genome that prevent this from happening, thereby preventing that gene from being read and processed. Finally, our DNA can be used as an instruction to make what's called non-coding RNA. So RNA, which is a kind of blueprint from the DNA, can be coding, which means it goes on to create the gene, protein, or it can be non-coding, which means that it cannot be used. So essentially, as you can see, there are chemical changes that can be made to our DNA or our coding genes that affect the usability of those genes. The fascinating part is that these chemical changes can come about from our behaviors, our choices, and other environmental factors. So while our genes are fixed and inherited, we have the potential to change our genetic makeup in affecting their ability to be read, processed, and manifested into traits. That is pretty remarkable in my mind and really gives us agency or power in determining our own fate. I want to repeat that and let's sit with that for a minute. We have tremendous power through our choices and behaviors, so much so that it can change our genetics. Wow. Believe it or not, epigenetic changes begin even before we are born. The science shows that, in fact, our parents' behaviors, which affects their genes, will also affect ours. For example, offspring that are exposed to undernutrition, maternal undernutrition, meaning the mom is underfed, or overnutrition, are at greater risk for chronic diseases later in life. We saw an incredible real-life example of this in what kind of ended up being an accidental human experiment. We have detailed medical records from a time in history called the Dutch famine that occurred in the mid-1940s. Detailed records were maintained of all aspects of health, including pregnancies and maternal outcomes that were followed up decades later. Researchers discovered that individuals who were in utero while their mothers were exposed to famine had epigenetic changes that were not seen in their siblings who were born either before or after the famine. In fact, when the genes of these individuals were sequenced 60 years later, they were shown to have lower DNA methylation at certain genes compared to their unexposed same-sex siblings. And these genetic changes were associated with a higher body mass index, or BMI, a higher weight, greater insulin resistance, higher cholesterol, and even a higher rate of schizophrenia in the group of people who were exposed to maternal undernutrition or famine in utero. Pretty powerful information in how the environment can actually affect our genes and our risk for chronic disease. Studies have also shown that overnutrition or obesity in a mother can result in epigenetic changes that increase the risk of obesity in their offspring. And that when mothers lose weight through bariatric surgery, for example, this epigenetic imprinting is resolved. Studies have also shown that the type of diet consumed during pregnancy can impact the child's dietary preferences later in life. I find this so fascinating, such that a mother that consumes a high-fat diet or a diet of processed sugars can be translated into a preference for a higher fat or a higher sugar diet in their offspring. For me, this is a major mind blow emoji right here. But other factors can imprint the DNA as well. For example, last week in our podcast, we spoke about childhood trauma, or the ACEs, also known as adverse childhood events. Studies have shown that there's a correlation between these traumatic or adverse childhood events and risk of chronic disease, such as autoimmune disease, obesity, heart disease, and cancer. And while that association is likely multifactorial, meaning lots of things are at play, scientists have determined that early childhood trauma has epigenetic effects that are in part responsible for the association with chronic disease. But this is not all about doom and gloom, because the good news is that positive lifestyle choices and behaviors also impact our DNA through epigenetics. Factors including diet, exercise, sleep will positively impact our DNA in an epigenetic fashion that protects us against diseases like insulin resistance and diabetes, abnormal lipid metabolism, obesity, and heart disease. The most compelling aspect of epigenetics, in my opinion, is its dynamic nature, in that we can continue to impact and transform our DNA in a positive way throughout our lifespan. Even the negative epigenetic changes need not be permanent and can be modified. This is seen in smokers, for example. Smokers tend to have less methylation at certain parts of a specific gene called the AHRR gene. Now, this is a gene that's involved in lipid metabolism and in male fertility. The difference in methylation is greater for heavy smokers and long-term smokers as compared to those who have not smoked as much. However, after quitting smoking, former smokers can begin to have increased DNA methylation at this gene. And eventually, they can reach levels of methylation that is comparable to that of non-smokers. So again, while negative behaviors can have a negative impact on our genetics, it is reversible and shows us that it's never too late to make change. Epigenetics certainly reframes for me how we view self-care and our agency in our own health. The fact that we can reconfigure our genetic code through our choices and behaviors has profound implications in terms of what we can do for our own health. It also reframes, I think, the way in which we see our behaviors and how it can impact those around us. As the science shows that our choices not only impact and shape our DNA, but they impact and shape the DNA and therefore the health and well-being of the next generation and generations to follow. Caring for ourselves is not only in service of ourselves, but also in service of those around us. It reminds me of the old adage that says, put on your oxygen mask first before you tend to others. Again, in caring for ourselves, we are caring not only for ourselves, but in doing so, caring for others as well. So I will leave you with this. To any of you who felt victim to suffer the fate of your genetics, to your risk of being overweight, having diabetes, having disease and disability, this is particularly for you because you are more than your genetics. You have agency, and you and only you determine your own fate. So choose wisely because what you do matters and you matter. So be well this week, podcasters, and join me next week for another short, actionable health bite. If you love what you heard, please subscribe. And if you think this message will be of service to others, please share. You can also find me on Instagram at Dr. Adrienne Udeem and find other goodies, tips, and a quick start that you can download now from my website at dradrienneudeem.com when you sign up for my weekly newsletter. Last but not least, I wanted to share with you a passion project of mine by the name of Del Nutrition and Del Bar. Del Bar is a high-protein, low-calorie nutrition bar made from functional ingredients that I have personally curated for weight loss, weight maintenance, better health, and well-being. You can find details at delnutrition.com. Here's to an excellent week. I'm wishing you health and well-being, and I'll see you next time. Bye-bye.